Assalamualaikum and good evening. My name is Ainur Zohaika Zainuri. For today, technical paper review, I'll be talking about Dip Moveout, where the paper that I will be reviewed is entitled Dip Moveout Processing for Converted Waves in Transervely Isotropic Media. The author name is BJORN, ROMMEL, and the year of publish is in 1996. The whole content for today is I'll be talking about the introduction, the problem statement, the analysis of content, and the conclusion. So before that, I will be talking about the author. The author name is Bjorn ROMMEL. He is the senior geophysicist in Norwegian German, and he is also has produced 16 in total of articles and conference paper. So on this paper that I've been reviewing, ROMMEL 1996 mentions on how DMO process for convert wave in Transervely Isotropic media. Before that, the whole objective of the DMO is actually the changes of the zero offset migration, because on this process they will be changing from the non-zero offset to the zero offset data. DMO is applied after normal move out, which is what we call NMO, on the pre-stack data to preserve the conflicting dips. It is also giving a closer representation compared to the conventional common midpoint. However, when the NMO plus DMO and plus the post-stack migration, it will give the alternative of the pre-stack migration. On this paper, according to ROMMEL, every explosion shot generates converted wave, which provide the extra information on the shear wave velocities. The description of the reflection move out enables to map the data to zero offsets and the image of reflector. Also, DMO operation presented for common offset gather proved to be an useful tools to map the reflector with help of the converted waves. Okay, so proceeding to the dip versus velocity. As we all know, the before migration, the dipping reflector appears faster and because the apex is not centered. While after the migration, the dipping reflector appears to be overcorrected. As what we can see on the graph, the left graph is the uncorrected CMP gather, where the graph is inversely proportional to the depth, where the no geological dip, which is a flat reflector, is in the dotted line, and the red line is a dipping reflector with the geological dip. So on the right graph, we can see there is a corrected CMP gather, which has been used using a velocity, where we can see a flat layer model, and NMO velocity is too slow for a dipping horizon. So the NMO will overcorrect the dipping horizon. Hence, the flat reflector before the corrected, it is going downward, while the after corrected, it appears to be flat, and the dipping reflector is increased. So proceed to the problem statement. In this paper, I believe that there have been some major concern about the effectiveness of the shear waves in DMO processing data and the impact of the presence of anisotropy in DMO analysis. So for the content of analysis, the move out analysis, based on the paper, displacement changes with offset and reflector dip, and the staking velocity will increase. This is based on Levin 1971. Anisotropy causes a further changes not only in the velocity and travel time, but also in the location of the conversion points. However, the travel time series for converted wave become extremely lengthy, even if restricted to weak anisotropy. This is based on Thomson from year 1986. So, the travel time series for converted wave becomes extremely lengthy, where we can see on the formula below, the where we can see the velocity denotes the p wave velocity, while g the velocity ratio of p and s wave. The local move out velocity changes with the offset, and also that the unique staking velocity cannot be defined. So proceed to the dip move out processing. The dip move out DMO operation maps every event into the proper zero offset location, and the travel time while sweeping over the all possible reflected dips. Because there is any DMO operator applied to converted data corrects for the displacement of the conversion points. The DMO operator itself is asymmetric based on Harrison 1992. Al-Faraj 1993, who extended till 1984 FK filtering DMO to isotropic converted wave, showed that the truncation of the travel time series after the third term results in an inaccurate DMO impulse response with only a constant lateral shift. So we can see on this formula 2 and 3 where the 0 denote to the midpoint and the 0 offset points. All these numerical calculations are used to obtain a reflector depth, the 0 offset points and travel time, and also the Jacobian matrix independence of the known midpoint location and travel time. Proceed. So we can see on this figure where the figure 1 is a DMO response of a band limited signal, where the amplitude is preserved. Second figure is the example of the DMO operators with increasing total travel time, but with a fixed midpoint. The numerical DMO operator does not produce the correct DMO curve with a varying lateral shift. However, in the figure 3, there is an example of DMO operators with increasing midpoint and travel time. The data is relocated into a zero offset position. Proceeding to the conclusion, for this paper, the influence of anisotropy causes the DMO operator to produce curves in the X naught to T naught plot, while the DMO is correspond in spatial exact domain, where the corresponding of the spatial domains look like a squeezed ellipse with a lateral shift and a deformed flanks. However, the figure is not mentioned in the paper. Before that, the general conclusion for the Dip Moveout data processing, the DMO will decrease as the depth is increased. Also, the DMO will increase as the offset is increases. Last but not least, DMO increases as the dip is increases. There are advantages of DMO, as we can see. It will eliminate travel path disparities and also to remove the velocity contention. For the main people working in the field, there are some geophysicists working on the implementing the DMO correction into precise and advanced, since the oil industry has become more reliant on the seismic data interpretation, and so the basic processing are no longer implemented in the field. So it needs a new and advanced method to actually to refine and outline to refine outline and detect the new trap. So the current debates, DMO are very time-consuming correction, and it is a very advanced. So the idea of where research will go next, based on my observation, uh, in the future time, there will be a research of enhancing the speed of the DMO correction, where to always improve the state of seismic imaging. So these are the paper where I refer to. One is from ROMMEL, Dip Moveout processing for converted wave in Transervely Isotropic media. And the second reference is actually from Levin, 1971, entitled Parent Velocity from Dipping Interface Reflections. So without further ado, that's all. Thank you.